Good day, everyone. My name is Jimmy Nguyen, and I am your host for today's webinar, Ask the MBD Experts from Design to Manufacturing. We have an esteemed panel of MBD professionals from technology vendors, industrial end users, and advanced aerospace supplier. So, a full spectrum of model-based definition in action. This webinar will last 60 minutes with our panel answering questions submitted during registration. We received over 200 questions and encourage asking more as we will diligently answer them during and after the webinar. This webinar is being recorded and will be provided to you, so rest assured. Lots of information to unpack and discussions to have, so let's get started with our MBD panel introduction. Daniel, it's all yours.
Yeah, thank you, Jimmy. Welcome, everybody. So my name is Daniel Campbell. I'm the Vice President of Model-Based Definition at Capvidia. I've been in this area of in the area of MBD really for a little over 16 years, with an eye on how to sort of figure out how to consume PMI from a downstream perspective. My background is actually more on the metrology side. And so as a company, Capvidia, my company Capvidia, is about trying to provide MBD tools so that our customers can create model-based definition workflows. And really the focus that we really focus on is the idea of downstream consumption, leveraging your semantic PMI in order to drive manufacturing from that single source of truth. Stephen?
Thanks, Daniel. So good morning, everyone. My name is Stephen Wurst. I'm with Sigmetrics. I'm the Director of Product Strategy, or excuse me, Customer Success and Product Strategy. Basically, that means I have the good fortune of managing a very talented group of people that work directly with our customers, whether it be the capacity of support or training or consulting services. Our company itself is very much focused on helping other companies produce better products through mechanical variation management. So we have an aspect of what we do and have been doing for a long time that's directly related to the topic of MBD as a cornerstone for MBD, as we'll get to in the seminar today. My experience, I've got over 25 years of experience in tolerance analysis and applying GD&T during the design phase, and with a bit of product management thrown in there as well. Evan, I'll turn it over to you.
Thanks, Stephen. Hi, my name is Evan Kessick. I'm a principal engineer focused on model-based enterprise at GE Appliances. I have about 15 years of experience in engineering and design. I do lots of model-based definition and GD&T training, and ASME Y145 Senior Certified. My main role at GE Appliances is guiding the business to implementing a successful model-based enterprise strategy. And we are the #1 appliance manufacturer in North America, and we have a house of brands that consists of GE, Profile, Cafe, and Monogram. And Coleman, you're next.
Thanks. Good morning, everyone. My name is Coleman Donnelly. I'm a senior staff engineer with Stryker. I've been working in the metrology field for about 20 years now, 10 of that with Stryker. And I work in a group where we focus on development of process to manufacture and inspect new product designs. So we focus mostly on the orthopedic market and creating a manufacturing process to deliver stable production of new components. I'll turn it over to Andrew.
Thank you, Coleman. Good morning. I'm Andrew Wilkes, and I've been invited here to offer a supplier's perspective on MBD. TACWA is a small contract manufacturer within the aerospace industry. We've been involved with MBD for a number of years at various levels. They're now looking for additional ways to integrate it into our manufacturing and verification processes. Additionally, we've joined with Capvidia in a partnership with an aerospace OEM to explore the integration of MBD into their processes. And I'd like to take this moment to thank Daniel, Stephen, Evan, and Coleman for the opportunity to be part of this discussion.
Okay, thank you very much, gentlemen. And so let's get to the questions we received. And the first one is, what is MBD and what is MBE?
All right, yeah, that's good. That's a good question to start it off with. Kind of lay a little bit of groundwork about sort of definitions of some of the terms that we'll be using. So MBD, model-based definition, MBE, model-based enterprise. And I think we might have sort of slightly varying definitions of these terms. To me, I guess the idea of model-based definition means defining your product using CAD and 3D annotations up front, and then trying to leverage that data downstream via the use of the CAD model geometry and the semantic PMI. And so that model, that MBD, that model-based definition, is sort of the technical foundation for bringing about the vision of model-based enterprise, which is simply the idea of using the MBD to power your enterprise in terms of defining the processes that flow downstream of design in manufacturing, and then also in terms of gathering data, especially from manufacturing and metrology, and being able to tie that back to that single source of truth. So for me, I guess, yeah, that's sort of the definitions that I think of. Stephen, what about you?
So very similar. I think fundamentally what it's about is trying to replace a lot of transitions of information from a piece of software to a human back into a piece of software, and let that information intelligently flow from system to system, both downstream, and be able to leverage that coming back upstream into the design phase. Obviously, with what we do, the emphasis we would place is on the annotations and making sure that the tolerance is defined and the way they're defined, the values and such are accurate. That's our niche in this big environment. And so there are various stages of that, but that would be kind of where we are kind of focusing our efforts in that stage. Evan, how about you?
Yeah, I would say that we see it as, model-based definition is the foundation for a good, successful model-based enterprise, right? So making sure that you are machine, so you talked about human readable, and we need to make sure we're human and machine readable, and that we have good semantic annotations that express product definition. So we see that as the foundation. So if you don't have a good strategy with a good model-based definition execution, then how you're leveraging that data downstream isn't going to be as successful, right? So a model-based enterprise is going to leverage that semantically rich data downstream, so we can use it throughout a part's life cycle creation, right? In all the various different states, creating a traceable digital thread.
Now, I tend to think of MBD as a subset of the model-based enterprise. For me, MBD is a system or process by which the design intent and form, fit, and function of a part can be conveyed digitally in a common language. Coleman?
So yeah, I think I would echo what's already been said. I think the model-based definition is really about having clear, full definition of what your design requirements are, so that it's very well understood and defined and not necessarily open to interpretation. And then kind of a model-based enterprise is how you take advantage of that clear definition and use software tools that can enable automated use of your design requirements.
Okay, thank you very much. And let's go to question number 2. What are the benefits of MBD? Coleman, we'll go ahead and lead off with you.
Sure. So for the benefits of MBD, really the value there is that you can have the clear definition that I was talking about, but also you can start to use software to automate a lot of the engineering tasks that you would normally do very manually. So because all of your information is defined in a software consumable file, you can pass that information into software to just automate your function, and you no longer need to program the software with all of the definition that's already available.
Okay. Adding to that, from a user's perspective, it reduces the amount of investigation, interpretation, and tribal knowledge required to manufacture and inspect parts. Importantly, it also reduces measurement uncertainty by accurately conveying the inspection methodology and not just the objective requirements.
So I'd like to add to that as well. There's a lot of benefits to a model-based enterprise and also leveraging that model-based definition throughout the enterprise, but it's about performing those lifecycle activities faster, right, and leaner. And we're doing that today through a lot of our PPAP report creation and also tolerance stack analysis. So I don't mean to steal Stephen's thunder here, but with software like CETOL, where we can consume native CAD data and PMI to perform analyses quicker, we're getting better data faster, right? And that's a huge benefit. But I would say that the benefits of what MBD is today is only the tip of the iceberg as more softwares come on board and we start to leverage this in more areas of the business.
So thanks, Evan, for commenting on one of the thoughts I had, and that is, as you said, the utilization of that information to help make the engineering analysis process of doing tolerance analysis and others as well more straightforward, more streamlined. I think MBD and MBE in general sets the stage for starting to capture a lot of data that's lost in the environment today in the enterprise. And once that is being gathered and collected in a way that is common, then we can actually start to make better decisions from it during the design phase. So using much of that information to start the next iteration of design of the next brand new design with a better understanding of what the reality is and have a closer target to actual rather than having to go through several perhaps prototype cycles as an example.
Mm-hmm. Yeah, I think that's actually one of the that you're touching on is one of the aspects that's often overlooked when talking about the benefits of MBD. Everyone thinks right away about the automation side of things or the idea of eliminating manual transcription, and that is obviously a very important element, and it's probably going to be the initial bit of ROI that people are able to achieve when they start with their MBD implementation. But the other side of it is the collection of data. I often talk about how in terms of throughout your enterprise, the area of your enterprise that gathers the most data is your metrology department. They're gathering a tremendous amount of information about the products that you're creating and the process that you have, which creates those products. And so to be able to capture that knowledge and mine that information and carry out, as Andrew had said once before to me, the idea of data forensics, that's huge. And so to take that data, which is already being gathered, and instead of throwing it in the trash or putting it, writing by hand on a paper and then scanning it to a PDF and putting it in a file cabinet somewhere, why not take that data and feed it back to design, feed it into some tolerance analysis software, for example? That's a huge benefit, I think, that people need to be aware of.
Okay, thank you very much. And for question number 3, is GD&T important? What if the MBD does not meet Y145 GPS standards?
So I'll go ahead and start off with this one. Obviously, this is kind of area that we operate in. I personally, and we believe at Sigmetrics it's critically important. There are just too many ambiguities with not using GD&T, with using traditional linear and angular plus minus dimensions with plus minus tolerances that are so subject to interpretation that we're so used to working with that we kind of do every day. And so I mentioned earlier, this transition is basically taking human steps out of the process. And so we're trying to send information directly from system to system to system. And as a result of that, you're going to lose some of those checks of that information that occur along the way naturally. It's going to be far more efficient. But if that information isn't correct to begin with, then system A system B getting the information from system A, if that information is not defined to a consistent standard, then it's not going to flow well. And so you're going to lose the benefit that you're trying to achieve by having somebody go in and say, okay, what's the problem with this? What do I need to change? And as a language itself, GD&T, there's a lot of benefits, and we could spend a lot of time on it. Fundamentally, I think one of the most powerful aspects is that there is no it defines a consistent way of defining the frame of reference for a measurement, and that's key. With plus or minus dimensions and tolerances, you can actually be measuring from 2 different surfaces and actually measuring in 2 different directions, depending upon how you establish the coordinate system of the frame of reference. GD&T eliminates that, and so it applies that consistently even before you get to MBD. But even more importantly, when you get into that environment, making sure that those measurements are done the same way. And of course, it has to be to a common language, hence the importance of making it compliant with the standards.
Yeah, at the end of the day, we're trying to express product definition through model-based definition, so 3D annotations. And GD&T complements that. So GD&T is important on all the things that Stephen just expressed, right? That common engineering and manufacturing language that helps communicate, functional pass-fail criteria downstream. and that's done through the datum system. But not only all the benefits that ASME, Y14 or ISO provide to you, but you gain, when you pair model-based definition and GD&T, you get that three-dimensional language. Right? You're not expressing things in a two-dimensional way anymore. We need to think 3D. And so GD&T is very, very important. Like Stephen said, we can talk about it all day.
Mm-hmm. Yeah, and I would add that I think one important foundational element of model-based enterprise is the idea of establishing a language that can be used across all of enterprise. And usually when people think MBD, they think simply about, let's say, the semantics of the data, or using your CAD system properly to properly define semantic PMI. And they might think that's enough. And that's enough on the data structure side of things. But the other side is just the mathematical side of things, or the geometric side of things. And that's what these standards like Y14.5 or the ISO GPS are for, is defining the common language for how to mathematically control things. So that's equally as important in my perspective. And I think we've seen from a lot of our users, lots of times, some of our users have a lot of success because it's clear that they really prioritize a proper understanding of GD&T.
Thank you very much. And let's go ahead and launch our first poll. Describe the GD&T GPS usage in your company. We don't use it. We use GD&T but not effectively, and we use it very effectively. And we're going to go ahead and close the polls. Share the results for our panel.
Mm-hmm.
Well, how do you feel about that, Stephen?
It's 50-50 there on the not effectively and very effectively, almost 50-50.
Yep, and that's consistent with what we've seen. The good news here, I think, is for an audience interested in more about MBD and perhaps starting your journey, or maybe already on your way, on your way of your journey to in implementing some MBE in some processes inside your organization. The fact that the 7% not using it at all number is quite low, and that's a good thing. Again, back to what I said earlier, I think that would be a very big challenge for those who are trying to go down this path and not adopting the language of basically controlling mechanical or dimensional variation.
Okay, thank you very much. Let's go on to our next question. Do you have any recommendations for implementing MBD?
Yeah, I'll start off with this one. So I think that you could take this a couple of different ways. I think that if you have leadership buy-in, or if you don't have leadership buy-in, I would say that that's the first thing. You need to get high-level leadership buy-in on your MBD strategy, right? They may not be able to see and conceive all of the benefits as of right now, but consider trying a smaller, simple pilot project to demonstrate those benefits that we talked about in the previous discussion. I would say, so start small, start on a pilot project, and also develop an upskill plan for your internal personnel and suppliers, because an upskill plan around, hey, we're going to be transforming the business from a two-dimensional data set to a three-dimensional data set, and let's prepare people for that, and especially your suppliers. Don't wait until you release and you send a technical data package and you say, oh, by the way, here's this new data set, and we're not providing you a two-dimensional drawing anymore. So I recommend, get ahead of the storm there.
So I'd maybe add to that a little bit that, as a sort of first step of implementing MBD, it makes sense to kind of start off small with how complex your implementation is. So there's a lot of different areas that you can sort of drive MBD functionality in. And I think that if you jump into the very complicated functions, that may sort of stall before you start. But if you start with something a little bit more manageable, like communicating information into software, or maybe creating documents and forms with design requirements and things like that your organization is already doing, you can find opportunity to gain momentum by saving time on some of the manual process of documentation without the burden of the complexity that you may have for very in-depth functions.
Yeah, I think just echoing both of those remarks, the implementation team really should include representatives from both the creators and the downstream users. Typically a cross-functional group, including engineering, quality, IT, purchasing, and select suppliers. Define your goals, develop a process that concentrates on value for all parties. Start simply and expand as goals are achieved.
Question number 5 is, what was the biggest challenge and lessons learned in your MBD journey?
So maybe if I start with this one, I kind of took the opposite approach of what Evan was just describing, of making sure that you get the sort of the top management buy-in before you try to start an implementation plan, where we sort of started from the ground up and defined all of these opportunities and started piloting them sort of on a low level. And then as we tried to scale that to different groups and units within the business, didn't understand what we were asking for. So I think definitely it's good to have sort of a full structured plan and communicate with your stakeholders in the beginning to make sure that you have buy-in, so that you're not trying to just implement this in pockets and pieces where you can't really take advantage of all the big picture opportunity that it offers, because you can very quickly run into resistance from a group that just doesn't understand why is there a need for MBD, and why is it important that we maybe do things a little differently than what everybody is traditionally used to. Anytime that you start to affect a change like that, there's a huge impact to the culture of how things have been done and what people are used to and familiar with. And it can't be overstated that you really need to consider, how are you going to change the way people do the work that they do currently without creating resistance in the process.
Yeah, definitely. I would say that, one of the biggest challenges that we faced, we had leadership buy-in from the beginning. So it was a pretty smooth implementation, transitioning the business to model-based definition. But our first phase of implementation was what we call human readable only, where we kind of had this mentality of just making our MBD look correct, where we soon realized, as we start to unlock the door to using Capvidia's MBD Vidia software to convert to QIF, which we use a lot in our workflows, we weren't really machine readable. So yes, it looks good per human, but how do we make these annotations? We kept saying in the beginning question, what is model-based definition? We have to use semantic references to complement the function of each annotation. And so, we had to overcome that hurdle, and we had to train our organization to kind of think differently when we actually create annotations that express product definition, so they can be consumed downstream.
Thank you, Evan. As a supplier, there are two areas that impact us. One is, introducing MBD within the company itself. How can we best use it? The other aspect is, what are my customer requirements and what are they mandating for me to do? Those two approaches can be different at times. And sometimes a single process will not suit both organizations. So for us, we're looking at adopting elements that give us the greatest success and return on investment initially for both us and our customers, where we can leverage that information, especially on internal processes. We can then demonstrate that to our customers, and hopefully that'll speed their adoption of the processes. But most importantly, the quality of the MBD data will have a significant effect on its ultimate success and adoption. And that's can't be overstated.
Yeah, I guess I would say, from my perspective, I've seen I think one of the biggest mistakes that I see is just trying to solve too much up front, and trying to bite off basically the entire, planning the entire model-based enterprise in one step before you even start jumping in. And of course, planning is very important, but it's also important just to get started on something. I think like Coleman was saying, and actually he's done a very good job with this. Just identify sort of the low-hanging fruits of what you think could show value, and then run this through on a pilot product or whatever it might be. Because for people, it's not about, in terms of convincing people, it's not about showing high-level concepts in a PowerPoint or something. At the end of the day, seeing is believing. And so when people see this actually being executed on their own systems, that's when they start to see that, oh yeah, wow, this is real and this is valuable, and yeah, we should do this. And then you can start to bring people on board.
Okay, thank you very much. And the big question, how do you encourage external suppliers to adopt MBD? I guess we'll turn this over to Andrew.
Thank you. Most importantly, supply them with accurate and consistently structured data. Partner with us let's develop a sustainable and repeatable process that concentrates on generating value for both of us. We often hear the term supplier reluctance, but this is typically not due to the technical requirements. Suppliers can be very adept in that area. Our reluctance stems from the risks surrounding the quality of the data that we are given and the non-value added contractual obligations that typically accompany it. Evan?
Yeah, seeing is believing, right, Daniel? That's a great phrase. So that's one of the things that we've done. Our supply base has been doing, trying to interpret model-based definition for some time now. And one of the things we've done is just visit with the supplier. So go visit with the supplier, show them the files that are inside of our technical data package, and show them what they're used for, right? Help them get over this competency curve, and show them the real benefits of how they can consume the data today with their current capabilities. We use CreoView for our light viewable. And so that was probably one of the biggest hurdles for us is we're no longer giving them a PDF, two-dimensional drawing. We're giving them a CreoView three-dimensional viewable. But show them how to use the software and show them the benefits of all the semantic data. There's so much ambiguity in a two-dimensional drawing, and after you see it through a three-dimensional viewer, why go back? But just show them how to do that. And I think seeing is believing and getting them to change their thoughts there. Yeah, no, that's right. I think working with the supplier very directly, I think, has its benefits. I know, Andrew, this is something that you've mentioned before, which I think is a great point, is that a smaller supplier might not have the resources available that a huge, mega aerospace corporation might have. But one thing that a smaller supplier does have is a lot more agility and a lot more ability to adapt to new technology. So in that sense, there's actually an advantage on the supplier side. And I know you've expressed that that often the discussion is very one directional, where data will be thrown over the wall and that's it. And if there's just a little bit more working together, then yeah, you can make some good things happen, right?
Absolutely.
Yeah, especially with QIF, as QIF becomes a big player in the MBD and MBE space, QIF is something that I feel like a lot of suppliers can really leverage to streamline a lot of their process when it comes to part qualification and that handshake of data. So I think that's something that we need to go and show them.
Yeah, I think it's important, right? You want to share your wins with the suppliers and help them understand why are you on this journey in the first place, right? It doesn't do any good to sort of just throw it over the fence and tell them, well, now everything is MBD and make it work, right? They have a lot of the same structures and workflows that you would have at the OEM level, just on a different scale. So they're still trying to solve very similar problems. And if it makes sense on a large scale, it'll probably still make sense on a small scale if you can share, what those opportunities are and give them some time to adjust and adapt. I think you get a lot more of a positive response as opposed to, well, now we don't have drawings anymore and we have all of these complicated models that you have to go figure out how to use right now, right? Time to adapt and share the wins.
Okay, thank you very much. Let's go to the next question here. Minimally annotated models, what is this all about?
I'll take an initial stab at this one, and I think this addresses one of the questions that came in the Q&A window. Basically, the concept here is the natural progression of minimally dimensioned prints that accompany a model. So if you just have a drawing, then you need to understand where each of those features are supposed to be. So that information needs to be put somewhere within the drawing, right? As the models started to accompany the drawings, then the things that were more critical have the tendency to be the things that are emphasized, either being the only thing shown, or perhaps with a flag of critical to quality dimension or some other similar thing. But the fundamental premise here is that there are some very important pieces of information about a part and how it interacts with the parts around it and what's necessary for fit and function. And those are the things that manufacturing really needs to understand are the important aspects. And there's other pieces about the information about that part that's not as critical, certainly from a tolerancing perspective. And so the concept here is to focus the annotations on really identifying those things that are the most important, the things that need to be within the stated tolerance range, and letting really the nominals drive the less important things. And you know, oftentimes there's a general profile note that's put in there that's defined to say, you know, for these other things, you know, try to fall within, you know, you need to fall within a broader range. But really trying to avoid all the noise that is so common when everything has to be defined with a number, and really help the user understand the importance of the critical features of the part.
I'd like to add to that if I can. You know, this is something that we do as well at GE Appliances, and you know, minimally annotated models. Think about that, right? So ASME Y14.5 specifies that all features must be fully defined. So the kind of old school approach, especially with coordinate linear drawings, is that I have to specify, I have coordinate linears all over my part, so it's fully defined. I can recreate this in CAD if I wanted to. But there's a lot of dimensions that we don't really care about, a lot of features that aren't really critical to me. I care that they're there, but I don't really want to know or qualify them at part qualification. So, you know, using a general profile note to capture all of that non-critical geometry saves you time. So time in annotating the model during, you know, the CAD team during creation, but also downstream when we go through qualification, right? I don't have to measure all of those dimensions that don't really complement the critical function of the part. So we save a tremendous amount of time in that aspect.
Okay, thank you very much. Let's move to the next question. QIF step 242 JT 3D PDF, which file format is appropriate?
Yeah, this is a common question, and actually there were a lot of questions that were submitted, you know, basically asking this, and I think the answer is that, you know, these are all good file formats that have their own purpose, and so the question really is what you want to accomplish. So it starts to get more into you know, much more technical discussion that we're going to get into today during this small, you know, 1 hour webinar. But these would be, you know, this would be the question that you would answer when you're trying to figure out, you know, the specific how of how you're going to do your MBD implementations. And there's a lot of good knowledge out there about, you know, which file formats would be good for which purposes. But I think that it's important not to, you know, sometimes I think people can get really wrapped around the axle about this question and get into almost religious wars over different file formats. And at the end of the day, I think it's important to take a step back and think, you know, these are all about model-based enterprise. And so the important thing is, you know, is model-based enterprise something of value? And is it something that as a company we want to jump into and address? And if so, you make a decision on that basis, and then you get into the technical discussion of, okay, how am I going to do it now?
Next question. What is your best guess when MBD will be common practice for the majority of companies?
Yeah, actually, there were a lot of questions that were submitted along this line as well. I think it's a question that everybody's asking, and I don't have the crystal ball on that. I don't have the exact answer. I think there are a lot of variables that come into play, and actually, I think different industries will be ahead of others. But I think clearly there's a sense of inevitability from everybody that, you know, X number of years down the road, be that, you know, 10, 15 years down the road, MBD will be commonplace, and that will be the you know, the standard practice, and drawings might be a little bit more of a thing of the past, where when you encounter a drawing, it's clearly a legacy part, or maybe it's a very a simple part or an unimportant part in some way. And so I think everybody gets the sense that this is coming down the road. It is inevitable. And so really, I think the big question is, how are people going to make this extremely difficult change from the 2D world over to 3D? And I think really at its core, that's what people are trying to grapple with. I mean, I can tell you that right now, I see this happening right now, that there's a tidal wave that we're seeing right now in terms of you know, organizations getting on board with MBD. Aerospace is already deeply into it. Aerospace and defense is already deeply into it. Yeah, medical's getting very into it. Heavy industry, automotive, consumer goods. You know, maybe slightly behind that, but definitely getting into it. So I think that, yeah, the tidal wave has definitely started. So you know, get ready to start seeing more MBD data.
And just to add not a lot to that, because I think that's about as good of an answer as anyone can have. But the industry specificness. So we saw this with other concepts, other value added, even GD&T and different industries adopting GD&T at different rates. So it's going to be driven by, in large part, the benefits that those industries see, the challenges that they have. I think everybody can understand and see a lot of the benefits of what we're talking about here, and in the back of their mind, probably have quite a bit of skepticism on how you're going to overcome this issue and this issue and this issue. But what's going to happen is you're going to see some of the industry leaders in different markets start to really explore this as a business value, right? How do we get a better product to our customers at a lower price? I mean, that's the constant evolution of what everyone's trying to do. And so the people that adopt it and implement it successfully, they're going to have a competitive advantage over the others in their industry who haven't. I mean, it's just going to be a natural evolution. So the different requirements on different industries are going to have different adoption rates and challenges specifically to address that we're not even covering today, but it inevitably will happen. And so I think it's certainly within a decade, and I think much shorter than that most of the industries will be.
I think maybe from an end user perspective, it's maybe worth just kind of mentioning that there's kind of a gap which people don't realize when they first start looking into MBD functionality, which is you have the CAD files that we've always worked with for forever that present human readable definition of a design. And this idea of software readable or software consumable is not really something that our design departments have come up knowing how to do well. And the software tools didn't really address how to do this well. So there's a gap between what is a design definition that is human consumable and what is a design definition that is software consumable. And as the design tools become much smarter at how they bridge that gap so that it doesn't require such sophisticated workflows for a designer to implement both software and human readable CAD. It's going to become more and more commonplace that these definitions are well defined and that the software can actually use this information. I think we kind of saw a little bit of a stall where PMI and MBD, these concepts of how to pass this extra information into software became technically possible, but we didn't have good CAD files to work with and really enable the technology. And now as those files become much more robust, there's kind of a snowball effect where more and more software tools become available to take advantage of the automated definition, as well as the CAD companies providing better definition. So as the momentum continues to increase, I think we're just going to see a trend of speeding up the implementation. And I would agree it's happening now, right? We're seeing that these tools are available, they work, they're functional, they're robust. It's not so much different for a designer to provide good standard CAD values, and software tools are starting to take advantage of that.
We can't move to 100% MBD overnight. How can I show value with MBD workflows using a hybrid approach?
Yeah, I think I'll start this one. I kind of mentioned it earlier. Really it's about identifying what is your low-hanging fruit. And to me, that's very much where is the opportunity to use software to provide human consumable CAD definitions. So things like documents and forms that your quality systems, your manufacturing systems are using right now every day. You probably find a lot of opportunity where engineers are creating those forms manually, taking advantage of passing that MBD information through software into Word files, Excel files, PDF files, or whatever other format you might be using. It's kind of an easy sort of hybrid step where you are automating sort of the repopulation of human consumable CAD definition before you start to really get involved in the software consumable. And you can sort of drive that momentum internally within an organization to say we're gaining value in this change to the workflow, and then it just kind of scales out from there into more technical aspects.
Mm-hmm. Yeah, I would say actually, I think that often when people, especially at a high level, try to look at where they could derive value from MBD in their organization, they often overlook metrology, because I think people aren't used to looking at your quality department as a source of value. Really, you think of it as sort of a necessary evil, something that has to be done, but doesn't really help make parts exactly. But in my experience, that's one of the lowest hanging fruits where you could find value is on the metrology side of things, rather than let's say on the CAM side of things, for example.
Yeah, it's important for you to pick those pockets of areas where you want to kind of streamline this. So, understanding the software capabilities that are out there today and how you can implement those is very important, because you can't go 100% model-based definition or better yet 100% model-based enterprise overnight, right? So pick those pockets, pick areas to test and to leverage, right? But knowing, setting up your model-based definition now the correct way using semantic references is only going to pay off as it goes downstream. Whether you're using it downstream in a model-based enterprise or 100% model-based enterprise, it will pay off.
To expand a little bit on the semantic definition, I think having the GD&T defined correctly, having it semantically defined, having the right tolerances in there in the fields is an essential aspect of MBD, as we've talked about. And if you don't have that today, then taking the steps to get that in place is only going to let you move forward more efficiently. At some point, you're going to have to make sure that the data that's getting defined is accurate to begin with. Again, as mentioned earlier, you're going to lose those steps along the process where people necessarily evaluating them as they put them into the next system. And hence, even if your MBD workflow or MBE workflow is not complete, taking the steps necessary now in anticipation of the next step of ensuring the accuracy of that data, I think is you can see that benefit without completing the MBE workflow.
Who should be responsible for creating MBD, design, manufacturer, or both?
I'll take a stab at that from an outsider's approach. Really what we're doing is we're creating information that's going to be used by multiple departments and possibly the supply chain. So I think it's important that the downstream users of MBD be involved in its creation. I believe that while design may have the major role in creating the MBD, engineering, quality, IT, purchasing, and the supply base needs to be involved in the entire process. Why purchasing and IT? Well, purchasing really need to understand what it is that they are buying, and they must be accountable for their role in the total cost of quality. IT needs to maintain ongoing compliance to regulations such as CMMC and IST 800-171 and ISO 27001. So I think having everyone, especially on the initial stages, set up a defined structure that allows full use and flow of the information is critically important.
I'd like to add to that as well. So I would say simultaneous engineering, right? So it takes a lot of people and a lot of departments to give input, right? So design, manufacturing, suppliers, and marketing, right? Not only design, we're trying to express product definition. So, engineering, manufacturing, and marketing all have to provide that definition. And it all goes into that single source of truth, which is your model-based definition.
Mm-hmm. Yeah, I mean, one thing about model-based definition is it does give you the opportunity to sort of define a lot of your processes up front. If you're operating under the assumption that your manufacturing workflows will flow from your model, then that does mean that when you define your model, you're sort of defining what your manufacturing processes are. And that's a good thing, but it means that you have to be very, very careful about maintaining communication both with internal manufacturing and actually that's why I really like Andrew's answer to this, but also your suppliers, where probably most of your manufacturing is actually taking place is your supply base. To keep that communication up, because their plans, their capabilities, and how they treat the data is going to now become a very important thing to consider at the design stage when you can take all that stuff into account. So yeah, MBD kind of becomes a communication challenge as well, where now your design engineering department that might not like talking to internal manufacturing, much less the supply base. I mean that needs to change.
Yeah, I think the alternative to that is kind of negative, right? Anybody who's not included in the conversation, you're kind of sub-optimizing your workflow. So there's going to be opportunity in places where you never considered up front. And when you bring those different groups into the conversation, you can really understand what's the best way to design a workflow so that you only have to do it once and not have to go back and keep on modifying your process because you hadn't considered different inputs and outputs that could be optimized through use of model-based design.
Thank you very much. And finally, our last question for today's webinar: what are the benefits of MBD for design engineers?
So on top of everything, everything that we've discussed today on the benefits of model-based definition, we've already talked about a few of these, but putting this in the eyes of a design engineer, a releasing engineer, why would I want to provide input or more time learning something new to help encourage model-based definition? And I would say that look at it from a lot of design releasing engineers do tolerance stack-up analysis. Right, so to be able to do a tolerance stack-up analysis using this semantic PMI that we create through model-based definition, I can get that 30, 50% faster by consuming that PMI into my tolerance stack analysis for a high level through multiple subsystem analysis. And I'm sure Stephen can weigh in more on the time savings there, but the other thing that I'd like to point out is think about from a design review, right? So from a design review perspective, that semantic PMI, right? Those semantic annotations can be used through some light viewer, like Creo view, and you don't have to have a CAD centric, CAD focused person with a CAD laptop in a design review. We can achieve the same review using Creo view, walking through all of the annotations, making sure all the semantic references are there, understanding the product definition. Whether we're doing that with internal engineering support groups or we're doing that with our suppliers. So there's a tremendous amount of benefit to a design engineer to want to push and move forward to a model-based definition strategy.
Yeah, maybe there's probably some opportunity with documentation as well, as far as how the designers document and communicate their design process. There's opportunity there where you can take the model-based definition and leverage that for automation of some of those functions. And it also sort of starts to talk to the concept of MBE, where you have the model-based enterprise, and now your data can flow back into your design sort of automatically. So it's not just kind of a forward-looking, but you can also look back at predicate designs that are maybe similar or have commonality with future designs, and start to look at the data that manufacturing process produces, right? I think earlier Daniel mentioned that we take all of this data and we just kind of stuff it into a file cabinet somewhere, and nobody really takes the time to mine all of the value that's available there. But with a model-based enterprise, really the idea is that the value should be identified instantaneously, right? So if the model-based definition gives us all of the information we need, and we use software tools with a model-based enterprise to handle all of our data, then when it comes time to generate a new iteration on design, we can look backward at all of that data and have that knowledge that it provides instantaneously without having to search for the information and try to figure out what makes sense. And I think a lot of times all of that knowledge sort of gets left on the table because it's just too cumbersome to try to go back and look at the mountain of information that's available there.
Okay, thank you very much. And here we are going to our live Q&A. So let's go ahead and look at a couple questions. The first one is, how do we transition the shop floor from 2D drawings to 3D MBD?
Yeah, sure. That's a very common question. I guess I'll just kind of quickly go through. I think it is a big challenge. People are afraid that on the shop floor, they're so used to, looking right away, they want their 2D PDF and they want their basic dimensions. I think it is a big challenge, but I think training with regard to GD&T, training with regard to modern technology tools, I think you'll find that people, when they see how these things work, that they will like them and will embrace them.
Yeah, I think it's definitely encouraged for, whether it's internal to your manufacturing or at a supplier, that to find a solution or to find getting that piece of hardware, a computer, a tablet on the shop floor to where you can start to view those, the 3D data. But also we do recognize that a lot of our quality management systems that we're seeing at our suppliers do require some type of a two-dimensional derivative. And so we allow a two-dimensional derivative to a point, but with the benefits of model-based definition and being able to annotate things in a 3D space, you cannot come to the same conclusion with a two-dimensional derivative. So that three-dimensional model-based definition file is still needed, even with that two-dimensional derivative. So it's definitely encouraged for them to look for that solution.
I think it's kind of that idea that a picture's worth 1,000 words, right? So if you just stick with your data where you have like a number or a table or a single value that represents, maybe a surface geometry, once you kind of show the picture as opposed to the number, I think you get very quick buy-in and adoption from people who are traditionally used to just looking at two-dimensional information, and they want that picture to tell them what they need to do much, much faster than, a series of numbers.
Can you say that you are following MBD process even if you are still using drawings?
Yeah, I'll take that one. You can, absolutely. There are different levels of MBD usage. Our customers present parts that are from legacy parts to modern parts, and they all require a different level. When you start including things like inspection planning, etc., these requirements do rely on some 2D drawing facets, the AS 9102, first article inspection reports, etc. So there's always going to be a combination of what is MBD, and yes, it can start with simply that.
Just real quick, I want to add one thing, and then we'll move on. You can still do a two-dimensional drawing. I think that there's a little bit of gray area there, but if you have your model, you can create all of your annotations in your model and show those specific views on your two-dimensional drawing, right? I think that somehow will still get you to a model-based definition and leverage that downstream.
One thing I hear very quickly, and we would go move on to the next one, but one thing I hear a lot of people say, well, you're talking about MBD or MBE, you're talking about a drawing-less environment, and that's not at all the case. It's just a matter of changing what is the master of the data. And in an MBD, MBE environment, the drawings are derivatives that are used for specific purposes in certain needs, and the models are considered the master. It's just a kind of a flip, but drawings are going to be around for a long time.
Okay, thank you very much. Let's go to our next question. Can you elaborate on QIF and its importance in MBD?
Yeah, so QIF is the Quality Information Framework, for those that don't know. And what it is it's a data format for sort of at its core, a model-based definition, a CAD model with 3D annotations. And then it has the data structures to add metadata related to measurement planning, measurement results, statistics, the resources that you'll use to carry out your measurement, and things like this. So a lot of metadata related to metrology. And so really, I think what it's about to a large extent is the idea of trying to come up with a way to instantiate, this idea of digital twin that's often talked about, where you want to have your product definition, and then you want to have your actual product that's being created or your process that's being used to create it, and you gather data on that real product or process and tie it back to the designed ideal. So that's kind of what QIF is all about.
Okay, and we have time for one last question. Is it required to fully dimension the MBD model? Could you provide recommendations on what features needed to be shown in the MBD model?
I touched upon this a little bit when we were talking about minimally annotated models. I think we've answered that it's not required, and of course it needs to. You need to have a common understanding with everybody involved in what you're going to be providing. The features that would need to be obviously, one of the benefits that comes out of doing a rigorous tolerance analysis is identification of what are your critical features. So that would certainly be one way of identifying those critical things that needed to be included in that definition set.
Yeah, definitely the critical features, but also I saw some questions in there about basic dimensions. And I think that's one of the values of model-based definition is that basic dimensions that locate features back to your datum features. Those dimensions a lot of times are queried from the CAD model, and we don't explicitly show those. If I'm a supplier or someone downstream, I can go and take that measurement knowing where my datum reference frame is located. So there's definitely some value there. So you don't need to show those specific annotations. But anything critical definitely needs to be shown explicitly through your model-based definition.
Okay, and thank you very much, everyone. That's all the time we have for today's webinar. I want to thank you to our MBD panelists for their time and answers, and thank you to the audience for your time and questions. Just a reminder, a recording of this webinar will be sent to you shortly. For those who would like to see more of what our experts will be doing, Daniel and Evan will be presenting semantic MBD workflows using Creo at LiveWorks, so definitely register today. Stephen and his team at Symmetrics provide expert webinar series on GD&T, tolerance analysis, and MBD, so definitely check that out. Thank you and have a wonderful day.